Hey everyone, this is FixReef, and today we have yet another Kessil light up for repair. So this is the grow light. This is an older grow light that has mostly red LEDs on it, and well, a few whites, I suppose, as well. Only one knob, has only three positions: off, grow, and bloom. And the problem with this light is that it's not working. It came in with an issue that it's not working. I don't know exactly what it is. I don't think it's a water damage issue. I haven't had a light like this yet. So let's take a look. Let's plug it in, see if it turns on. Then if it doesn't, open it up and see if we can repair it. So this is a 19 volt input, so pretty straightforward. To avoid damage, I'm not going to give my lab power supply too much current, just a little bit, just to make sure that it attempts to do something. Let's turn it on. So currently it's in off position, so we should be okay turning it on. And even in the off position, my lab power supply says that it's a dead short inside. So let's disconnect and start disassembling. A dead short may mean a variety of things. We'll need to find out what exactly it is. A little bit of corrosion on the knob, but we'll lose. It looks like this was, it had a mounting bracket that was removed previously. So with the mounting bracket removed, we should be able to pull the cover off, but I also need to remove the bottom part or unscrew the bottom part so that it slides out easily. So let's get that done. And now let's get the top part off. Got a couple of clips here that need to be disconnected, and it should be out. The light is actually fairly clean on the inside. I've seen, and you probably have seen by now on my channel, Kessil lights that are much, much worse than this. I have to assume that have been cleaned, although you can see quite a few of the dead bugs inside. So by the looks of it, it's not a terribly old light. The the date stamp on the original, I have to assume this is the original fan, is 2017, so just about 5 years old, give or take. Other than that, the light is fairly straightforward. Like I said, there are only a couple of channels here, mostly red and white. Nothing much more than that. But it does have, a controller. It does have a fairly complex circuit compared to older Kessil lights. But what the reality is right now is that we have that short on here. So let's do a little bit of testing. As a matter of fact, let's remove the board first. Okay. Now with the board completely off, now we can finally do some testing on this. Multimeter in the diode test mode, and see if we can immediately find the short. So the power comes in over on this end, and right there, short on the power. It could be this diode. I can totally see how a diode could cause this. But let's keep testing. Doesn't look like it's a diode. There is a short across this capacitor. Might be the capacitor issue. Over on this side, we also have a couple of capacitors, and it looks like a couple of diodes. Yeah, so So there's definitely a short. So what I'm going to do now is I'm going to do essentially a voltage injection, apply some alcohol here, and see if anything heats up at all. All of the Kessil lights, no matter how old, have conformal coating on it, so it's going to be a little bit harder to find the short, but we'll give it the best shot we can. Power is on. It's a dead short. Everything drops. The current, the voltage drops immediately. So there is a short somewhere on here. Usually that much of a short manifests in the heat. And now I can feel it. It's in one of the channel circuits here, which suggests perhaps a MOSFET. All right, let's see if I can zoom it in so you can see. Even with conformal coating completely still entirely in place, let's see if we can get evaporation going on this on the circuit on the right. Let's try. Looks like one of these diodes. The one, what is it, D1? Seems like that's the problem. Let's try it again. In fact, let's get under the microscope and take a closer look. It's harder to see in at this magnification. Okay, this is our circuit. Let's start applying some alcohol, and I'm about to turn on. Right now, everything evaporates so fast. It doesn't evaporate, it just moves around so fast because of the conformal coating. I'm going to just apply the power and see if there is anything that's going to evaporate even faster. By the looks of it, it's the MOSFET. It doesn't even stay on it. Immediately gone. So I'm suspecting the MOSFET. This MOSFET is what is it? Q1 MOSFET. So I think that's the one causing issues. Let's poke around with the multimeter real quick. I would imagine that there is a short across these diodes as well, but maybe not. But there is definitely a short across the MOSFET. Let's see. I think the MOSFET is the problem. Let's clean up. Let's remove all of the conformal coating from the MOSFET and find out what type of MOSFET that is. And without conformal coating, we can also easily test for the heat as well. All right, looks like a standard MOSFET that I've seen in most of the Kessils of that generation. Let's apply the power again and see if it immediately heats up. Okay, so here's our alcohol. It's staying on. Now the power comes on and it starts drying up. Not as quickly as I would expect it, but it dries up. Oh, that is very interesting. The short is actually gone right now. The short is actually gone. I removed conformal coating and the short is gone. What is that? Okay, let's turn on the light. And now the short is back. That is very interesting. That is very interesting. All right. Oddly enough, the short is somewhat intermittent. Let's see if the short is back. Right there. See it? immediately that MOSFET completely evaporates. Immediately. For some reason, the short was temporarily gone when I touched and tested the MOSFET, but then it started doing this again. So I think that we've seen enough. Let's remove the MOSFET. Let's remove the MOSFET and see if this. Oh yes, look, the MOSFET is actually getting. Look, I don't even have to. That is very interesting. I don't even have to use my hot air to remove it. It comes off. That's why the short was temporarily gone, because it got disconnected. So I'm curious what the condition is under of the board under the MOSFET. Wow. I don't want to rip it off, because if it just disconnected from one end, it doesn't mean that the other end is completely disordered, and I don't want to damage the traces. Okay, I think that's good enough. It's time to apply some hot air here. And off it goes. Okay, with the MOSFET off, I want to fully understand why it actually came off. It's possible that it heats up to the point that it melts the solder and comes off, and I can totally see that. But it's also possible that it shifted at some point, perhaps causing a short. And it was just a bad solder from the factory. So first off, let's find out if the short is still present. Unless I have a bad connection, it looks like the short is gone. Let's test at the inputs. And I think that the short is gone. All right, so, and finally, the real test is on the MOSFET itself. So here's the back of our MOSFET. So if I connect this and this, I have a short. So this MOSFET is definitely gone. Everywhere. Okay, well, we know that the MOSFET is bad. Okay, so with the knowledge that the MOSFET was bad, we've removed the MOSFET now. And technically speaking, there shouldn't be a short on this board anymore. So I'm going to connect power again to this and try to power it on. And the question is, will I be able to see any other of the channels lighting up? I don't know which channel this is, but obviously that's the bad one. There are 3 more like this, and in theory, if everything is good right now, 3 of the 4 channels should be on. So let's power it on. There is no short. At least my power supply is not showing any shorts. So let's power it on. And look at this. The light is on. Not every single channel works on it, but we know that the other channels seem to work now. So I think we found our culprit. That was the MOSFET. All we need to do is just replace the MOSFET on this light, and the light is going to work. To do so, again, I will have to clean up the area, get the new MOSFET. For that matter, let's get the new MOSFET now. One of this should work. And now let's jump back under the microscope and install it. All right, let's remove the old unleaded solder. And also remove any of the conformal coating that's in the way here. All right, and now we can apply some fresh solder. This might be a little bit excessive, so I'll probably remove a little bit of extra solder. And that's much better. All right, so now that we have it, let's remove the excess. Let's clean up this area real well. Do some more cleaning once the MOSFET is in place, but just getting rid of the old flux and pieces of conformal coating makes more sense to me. Okay, that's good enough. And let's put the new MOSFET in place. Position it something like this, and heat it with hot air. It doesn't have to be perfect right now, just melt the solder. And it's going to get in position itself. I think that's good. Probably would be a good idea to remove the excess solder, which we do with an extra bit of flux here and there. Just like that. And there you have it, something like that. All right, now just to be sure, I'm going to test to make sure that the short did not come back. Looks pretty good. Nothing's beeping. Yes, I think the short is gone. Okay. So now the final test. I'm going to power it on. It's not showing anything shorted yet. And now I'm going to attempt to turn it on. The light is on and the fan is on. It's extremely bright for you right now, and even brighter. Looking through my filtering lens, which you wouldn't be able to see. Let me see if my camera can capture this. Likely not. No, it's not going to be able to, because this light does not have the brightness control. You can't really see. But through my lens, I can see that all of the channels are on, all of the rows of LEDs inside are on. I would consider this light fixed. One last thing that I would like to do, since we removed conformal coating from this area, I'd like to put some fresh one on so that this whole area is sealed just like original. It dries up and it will be like new. All right, the light is finally fully assembled, and let's test it again. It's working. It's at full intensity. At full intensity, it's consuming about 3.5 amp at 19 volts, and that's where my power supply is at right now. The fan is spinning. The light is working. Well, let's just review what we've done. There was a complete short on the inside. I know that you've seen in my previous videos with Kessil lights that when there is a short right off the get-go on the input, usually it means one of the diodes that are filtering diodes at the power input. But it's not always the case. I have seen and I have worked on so many Kessils by now to see that it's really 50-50. Half the time it's the diode, half the time it's one of the LED circuits. And in this particular case, that was the situation. The LED circuit, one of the 4 LED channels, was completely shorted because of the damaged MOSFET. These MOSFETs I have replaced plenty of right now, by now. As you can see that each light has like 4 of them at least. they do burn out eventually. And replacing that MOSFET made the light work again. It wasn't as difficult by now. I know exactly what temperature to apply to get the MOSFET off safely, how to put one back on safely as well. What was interesting with this light is that probably because the MOSFET got so hot, it got desoldered itself from the board. When I removed the conformal coating, the MOSFET came off pretty much right away without any additional heat applied. That's actually very telling because the temperature needs to be in like 300s. Needs to be at least 300, maybe 350 Celsius around that MOSFET for it to be disordered like this. And it was disordered, so it got real hot at some point and came off. But that was not the reason the MOSFET failed. The MOSFET failed first, and then it got disordered due to the heat caused by the short. But it looks like it didn't damage the rest of the circuit, which was great, and we were able to repair this light fairly quickly. Well, that concludes this repair. If you enjoyed this video, please like and subscribe, and I will see you next time.